Stop writing prompts and start thinking in tokens because that's how AI actually reads. Not sentences, tokens. The atomic unit of LLMs. So when you type a prompt, the model shatters it into tiny pieces, the numbers, the fragments, the signals. That's what it actually understands. If you don't understand tokens, you hit contextual limits, you overpay for APIs, and your AI starts hallucinating halfway through a conversation. So, in this video, I'm going to show you how tokens actually work, why they break, how engineers should optimize them, and let's open the map and let's start learning. Alright, so now we are going to talk about Token Masterclass, and there are 6 things which I want to cover, a lot packed in it. Let's get started. First of all, I would like you to understand the technical anatomy of token, context, and context window. Next, we will be moving with the context scenarios to make you understand the quick wins which apply to your program, your plans, your any of the tooling you are using these days. And then we are going to go into bit more deeper into core constraints which this token, the context window, and things like that produce. After that, we'll be moving into the optimizations, the how-to part of it, that how you can apply a couple of techniques around it. Last but not the least will be the shock. Certain shocks are necessary to give for the hallucination realities to understand, because hallucination is the word which is getting widely used. However, it's not just the hallucination. There are many such problems these days which LLMs and the Gen AI throwing on us, but we only know the fun problem, which is hallucination. So, what are those problems? You need to understand those. And last not but the least, AI engineers and architects, goodness at the end, we'll be sharing. So, let's get started. To understand Token Masterclass, I'll be going into technical anatomy now. Stay tight because this is going to take a little bit of time, but once you understand it, everything else will fall in place. Now, what is the token? Let's understand this with this diagram. Thing is that Gen AI is all about LLMs today. There are various researches which are happening which will go beyond LLMs, but today Gen AI is the centerpiece of AI which most of the people are talking about. And Gen AI heavily relies on large language models or models of various sizes. Now, when Gen AI relies on LLM relies on tokens because that's the language which LLM understand. It's the most atomic unit which LLM works on. For example, if we take a plain text called the AI architect. Now, this may split roughly like the AI architect. But the important thing here to note is that these kind of tokens, because different models split differently, but the idea remains the same. Some models might split it in different forms, but let's say broadly it divides it into the AI architect. Now, what happens here is the number of tokens which come out of this breaking of the whole sentence is approximately 3 tokens. This is only a rough approximation. As I said, different models chunk it into different parts. Now, tokens alone don't do much because it's not just the input which user prompts and gives and that works. It actually combines it in the form of context. Now, context is all about the tokens the model can currently see while generating the next best answer for you. It means when you send a prompt, it's not that only that prompt input gets sent to the large language model. It actually sends you the developer instructions, chat history, your latest message, retrieved documents, tools you are using currently with this, whichever tool you are using, and that total makes it to the current context window. That whole thing, which is also in the form of tokens, get passed on along with your inputs. So context is not just the history. Most people think that whenever I'm chatting with the chat GPT, whatever gets stores in the chat, that is the memory which it gets passed. No, it is much more than that. So the entire instructions, the chat history, your latest messages, configuration piece of it, which is associated with your tool, all that gets passed in. Consider this post-it is a full area in that post-it. The information which I have passed in that post-it is the AI architect, but it doesn't mean that this post-it can only contain what I am seeing now. This post-it can contain much more than that, or it might be containing that. So this entire thing is called the context window. That's one example. Let's look at one more example. Now, the next example, which is very easy for anybody to understand, is if this is a Coke bottle I have, it has full capacity of whatever this 200 ml or measurement bottle this is, but currently it is half filled. It is filled till here. So this is what you see as the token you are sending, but actually speaking, this has whole of this context which gets filled up, and that's what gets passed on to your model. Now, to put this all together, example, imagine a model has a room for 1,28,000 tokens, 128K roughly. Now, if let's say this is the maximum limit of a context window which you can pass at one time to any model, this is roughly for a GPT-4 model, 128K tokens. So if let's say because of my chat history, the files I'm passing, the rag docs I'm giving, my chat hits history, which is taking the maximum size here, and whole thing is now reaching to 136K, which means I'm definitely crossing this limit of 128K, which is permitted to me. So in that case, what happens? Something or the other will be dropped, and you don't know, you don't have control over what gets dropped. So that's where we need to be very mindful about, not just that token is the new currency, but token is also important to get going with your LLMs and any sort of tooling you're working with, agentic powers or anything. You need to understand that how your tokens impact your output as well. This is a nice way to understand that whenever user sends a message, model response goes at output. In previous turn, whatever you have sent, that also gets combined. In previous to that turn, if you were chatting or giving it some inputs, that also gets combined. So that's how you will see that context window every time is increasing. Here it's showing 200K tokens, which is a lot. If your tool permits that, well and good. If it doesn't, then it will start creating problems for you. Whatever I'm doing with this tool, it shows you these days almost all tools are giving you this power that 19% of context is already used. So it means if I've just started planning for my project, developing something, and if it reaches the 100%, it means I have consumed whatever is for a monthly or a weekly being allocated to me. Now that we understand token, let's get back to what more in the technical anatomy. Why you should care about it? Because there are situations like lost instructions. So important rule is buried into too much text. If you are using too much of outside your context window, the important things will not be noticed. Your system will start hallucinating. The model did not receive the right context which it needs. So that's very important for you to understand. It costs you, every token costs you. So, and there are limited number of tokens which you pay for. So you definitely need to understand it better. It slows you down because when model gets confused what to pick and what to drop and you are loading it too much, it directly impacts the latency and the response time, because token per second which it processes with the speed, that also gets slowed down. Last but not the least, wrong answer from the correct data is also a possibility, and we'll see a few examples. Okay, now I understand token, but does it really impact me? It will. Even if you're chatting today with AI through ChatGPT, Gemini, or any other tools, which hopefully you have started doing. If not, then you will be reaching to these stages where tools like, and I'm giving a couple of examples here. For example, you're using OpenAI or Anthropic APIs, then token usage and limits that can hit. If you're using LangChain and LangGraph, then memory and prompt assembly takes tokens, and that's what you need to be mindful about. If you're using Llama Index, document chunking and retrieval takes tokens. Vector DBs, relevant chunks for context, and that's how DBs manage themselves. Observability tools. More and more tools are coming with the intelligent information. That's where they use token cost, they use latency, they use prompt size. So what we have understood so far is token is the smallest text unit the model reads. Context is all tokens currently visible to the model. Context window is maximum amount the model can handle at once. And that's what you need to be mindful about. With that said, we have understood the anatomy. Let's move on to certain algorithmic parts of it. Now, what happens is when you give the raw talk text to the a tokenizer, which is usually the algorithms like BPE, which is byte-pair encoding logic, and there are various such encoding and decoding logics these days. But let's say BPE logic or the BPE tokenizer gets used, which then chunks these into tokens. Tokens get converted into token IDs, and token IDs further get clubbed based on the significance of the information, and that's how the LLM understand the next best and next best answer. So those embeddings gets passed on to LLMs. Why BP is powerful? Because it handles unknown words as well, and that's how the it enriches the vocabulary of LLM. Okay. Now next comes is how this text to numerical ID happens. Now let's go a bit specific about the models. For example, GPT-4, Claude, and Llama. Three things. Let's say you have GPT-2, which is using BPE, byte-pair encoding. We have just seen GPT-3 uses BPE variant. Roberta uses BPE. OpenAI models uses the same. But then there are other popular such encoding algorithms like word piece, which is used by BERT models, Google, sentence piece, which is used by Claude and some other popular tools out there, Unigram LM, and more. Now, a bit more I want to talk about with images, videos, audios, and more. So to make you understand the multimodal functionality of this, let's see how it works. In case of text, it is tokens. In case of images, it is patches. And in case of videos, it becomes the frame patches. Now, how does it work? It works like give the input for processing. That image gets patched in the form of like this. So if this is my image, the whole area gets divided into P1, P2, P3, and so on. Each patch then counts as one token. Now, once these patches are splitted, then it gets converted into patch embeddings, like for any other token, and that gets given to the transformer for extracting the features and insights from that image patches which it is working on. So that's one example to help you understand how tokens still valid for any multimodal systems, but they have further more granularity or ways of processing those tokens through images, videos, etc. This information. Now there are 5 optimization areas, 4 to be precise, which you can use. Pruning. Now, removing redundant adjectives. Now, that's very important for you to understand. Whenever you are prompting and if you're giving too many adjectives to it, it confuses your model because there are competing tokens which have gone there and it creates problem in terms of figuring out the next best response. That's the way LLMs work. Second is formatting using Markdown. So this is one optimization technique. Wherever you have an option to give code or markdown, use that, because words is like take too much of space, but markdown says the same thing in less tokens. For example, if I have yes, so let's say if I'm writing that please summarize the following document in 3 bullet points, each bullet point should contain one key idea from the document, the summary should be concise and easy to understand. While this is mouthful, same thing if you do through Markdown. It says that task is summarize, output should be 3 bullet points, one key idea, be concise. How small it is. So it saves a lot of tokens. So that's what you should be taking care when you are writing your prompts. 2 more things: compression, summarizing history. Use the compression algorithms, and that helps you in summarizing the history in the way. There are more modern tools out there, but as of now, we are not covering it. We'll come to that later. There is another thing called tick token, testing counts before sending. Now, here, let me show you something which will be very handy for you to use as well. So, let's say I have this tokenizer, which is I am on OpenAI platform and I'm using this tokenizer tool. You can use platform.openai. All right. So you can see here it's using GPT 5.x and it's giving me tokens are used 3, characters are 16. How does it chunk through this colors? You can see the AI architect. That's how it's chunking it into 3 tokens. It also giving me the token IDs which it is converting into and some instructions. So it's saying, I'm not sure you're able to see it. Let me make it broader. Okay. A helpful rule of thumb is that one token generally corresponds to 4 characters of text for common English word. This translates to roughly 3/4 of a word, which is important to understand. And if you need a programmatic interface for tokenizing text, check out our tick token package. That's what I was showing you on other side of the screen. Same thing if you'll see in other model, it might take less characters. As of now, it's 3. But let's say if I'm giving the bigger text, I'm copying it from here itself. So here in GPT-3, it's using 49 tokens. Again, for 49 tokens, let's see if this makes any difference. Not now. GPT model looks to be similarly working. And if I move to, where is my text gone? Yeah. So here, if you see OpenAI, how is it chunking? There is no logical human relatable understanding here, but open is 1 token, AI is 1, exclamation mark, and S is another, and so on. That's how things work. But you can play it around and see that whenever you are giving a prompt, if you want to play around and see that what is more optimized, you're using markdown or other things, come here and play with that, and there are more tools which you can use. All right, this out of the way, we have last 2 things to cover, and quickly I want to give you some shocks, the ones, not the difficult ones. The shocks here is, so I was telling you in the beginning that hallucination is a most hallucinated word used today. What I mean by that, I mean that people are saying that output is hallucinated. Actually, hallucination is just the one problem which your LLMs give you because of this token and context window and too much of input or output if it produce. So lost in the middle, accuracy versus depth. Now, what happens is, and we'll take one example to understand that. Okay, let's say LLMs often ignore information placed in the middle of long text. For example, you are giving the context of 10 pages of logs, and important line which you are looking for is on the page 5th, which is like payment API timeout is equal to root cause. Now, when LLM answers it, if it is lost in the middle kind of problem in the context, it either refers to the beginning or the end and it loses the middle. So it might give you, it will just focus on page 1 or page 10 instead, and it will not give you the right root cause for this particular problem which you might be facing. It'll answer you, it's smart. I mean, it doesn't want to say that I don't know. It will still answer you something, but that might be wrong answer or not the complete answer. Let's see another example, the X factor, the 70% reliability drop. Now, what happens? Another example, let's take. If you give a simple prompt, it will give you 95% accuracy. But if you give complex multi-step prompt and in the same chat window you are loading it with the too much of context, then it might go till 70% correctness. So if you say summarize document, it works well, but when you say summarize, analyze, detect, generate strategy, it drops the accuracy. Now we have also, I've been seeing it in my experience, but now we have a paper with support. So if you're interested, I'll drop this link in the comments below. Go and check. This paper scientifically supports that LLMs get lost in multi-turn conversation. So we should always try not to have complicated conversations going in one thread till the time LLMs are able to better handle that. Go, and once the context gets started overloading, close that chat, open a new one, give it your history in short, and go further about it. Okay, there are 2 more things which you should understand. Logic drift. Now, context overflow symptom. This is an interesting problem actually. So, when contexts grow too large, the models slowly drift from the original instructions. Let's say system rule is only answer using company policy, and this is one of the clearly stated thing which you're giving as a governance thing. Later in long chat, model will do what? It will invent its own external information if it's not able to reach to that information because of context loss. So it drifts from the logic, and that's another problem. Okay, another needle in the haystack problem. I mean, if you're finding a needle in the whole stack, and if your context is so full, it will give you that problem as well. Let's see it with an example, an interesting example actually. Now, sometimes models struggle to retrieve a single information fact hidden in a large document. If it's 100 pages PDF and you're looking for one line like database password should be rotated in how many days, and you're querying it, what is the password rotation policy? Model may miss the line completely. And that's where the tokens and context window is important. So many things which you only knew by the name, maybe hallucination, and this is your time to understand that. We are towards the end of our AI engineers and architects goodness with the token masterclass. One last tip I want to give you: these four problems all come from the same root issue: too much context, too little signal, which is why modern AI systems use retrieval, re-rank, compress, and then generate. This is another topic to deep dive when we have time, and if you're interested, I can create this video and share with you. But you now understand the language AI actually speaks: tokens, the atomic unit behind every prompt, response, and context windows. Most people keep guessing with prompts. Engineers and architects optimize tokens. If this helped you see AI differently, subscribe, because on this channel we go beyond prompt tricks and break down how AI systems actually work. Next, we are going deeper into context limits and how they silently break AI applications, what you should do about them. Subscribe so you don't miss it. And if tokens just changed how you see AI, comment DNA in the comments. I'll see you in the next one.